So let's try to solve this differential equation by using the method of variable separation. But before that, we have to reduce it to the variable separable form. That can be done by first supposing that x plus y is equals to a variable v. Differentiating both sides with respect to x gives us 1 plus dy over dx equals to dv over dx. So dy over dx, that's equals to dv over dx minus 1. Now we will use this to substitute dy over dx with dv over dx minus 1 in the original equation, such that we get dv over dx minus 1 equals to tangent of v, which is dv over dx equals to 1 plus tangent of v. Now separating the differentials, we get dx is equals to dv over 1 plus tangent of v. Now this is reduced to a variable separable form. So that means we can integrate both sides. To integrate the integral on the right hand side, we'll use some techniques, some trigonometry techniques. So let's begin. We know that the tangent function is the ratio of the sine function and the cosine function. So we replace tangent with the ratio sine over cosine. So that should give us cosine of v divided by cosine of v plus sine of v. This is dv, which is now then we will do is like we will multiply and divide by 2, such that the numerator can be written as cosine v plus sine v plus cosine v minus sine v. So this is a technique that we are going to use. So what we have done, just look at the term on the numerator carefully. So here we have added and subtracted an extra term, which is sine v. So this does not affect the numerator. Then cosine v plus cosine v is simply 2 times cosine v, and to get rid of the 2, we have to multiply by the factor half. Now the reason why we have done this is so that now we can simplify this as 1 plus cosine v minus sine v divided by cosine v plus sine v dv, and this is a integral dx. So this should give us integration of dx will be simply x. Then we have half integration of 1 times dv, so that's v, plus integration of cosine v minus sine v divided by cosine v plus sine v dv. Now this is a very simple integral. Here we can use the method of substitution, and if we let the denominator cosine of v plus sine of v equals to t, then we will get the numerator cosine v minus sine v dv. So that means our answer will be natural log of the denominator. So that's cosine v plus sine v plus the constant of integration c. So we used v is equals to x plus y. So that means x, the far will be equals to half of v. So v is x plus y plus natural log of cosine of x plus y plus sine of x plus y plus the constant of integration c. And when we simplify it, this is a very simple simplification, algebraic simplification. That should give us the final answer as x equals to y plus natural log of cosine of x plus y plus sine of x plus y plus the constant of integration a. So this is the required solution to our given differential equation.